All right, I'm going to combine the next two questions. They're really just one question. It starts off with asking you to balance the following chemical equation and then asking you about calculating the number of water molecules produced if a particular amount of manganese 4 oxide reacts. So let's start off with balancing the equation. It looks like I've got 4 chlorines on the product side and only 1 on the reactant side. So I think I'll start with that. And then the only other thing that needs to be balanced is the hydrogens. And so I think I'm done now. That took care of oxygens at the same time. All right, so now that I have a balanced chemical equation, I want to go ahead and solve this particular stoichiometry problem. And stoichiometry problems also lend themselves very well to conceptual planning and dimensional analysis. So I'm going to solve those problems in that fashion. So that means sort of coming up with the 3 items. First, what you're given. I'm given 0.86 moles of manganese 4 oxide. I'm asked to provide the number of water molecules. And that means the basic plan will be to convert the units in 1 to the units in 2. So moles of manganese oxide to the number of water molecules. Now, stoichiometry introduces the chemical reaction, and the chemical reaction is what you use to do conversions between moles of one species and moles of another species. So in this case, we're asking to convert moles of manganese oxide to the number of water molecules. There isn't a direct relationship, but I can use the chemical equation to make a relationship between moles of manganese 4 oxide and moles of water. Once I have moles of water, I can use Avogadro's relationship to calculate the number of water molecules. So we'll come back and we'll examine the chemical equation in a second as I put this together. So I start with 0.86 moles of manganese 4 oxide, and I'll multiply it by a relationship between the balanced chemical equation. The balanced chemical equation tells me 1 mole of manganese oxide will produce 2 moles of water, and that's how I write the per expression. 2 moles of water per 1 mole manganese oxide. The other relationship is Avogadro's. We know that one, 6.022 times 10 to the 23rd water molecules per mole of water. Putting it into my calculator and rounding to the 2 sig figs, I get 1.0 times 10 to the 24th water molecules. And that is the final answer.